Hello friends, I'm Nikita and you are watching Prepare for GATE. GATE is a competitive objective examination. It has 65 questions of 100 marks. The duration for this exam is 3 hours. So not much time is given for you to solve 65 questions. Moving with our lecture series on communication, let's discuss today's topic that we are going to discuss. Firstly, amplitude modulation and demodulation, the spectra of AM, a demodulator known as superheterodyne receiver. So, the topic to be discussed will be, as in reference with the syllabus, is amplitude modulation, demodulation, spectra of AM, figure of merit of amplitude modulation, and superheterodyne receivers. What is amplitude modulation? Now, in communication, there are three types of variation that helps in modulation. That means modulating a signal so that it can carry an information. In communication, a signal x of t is equals to a of t cos omega t plus theta t, where t is the time reference. The signal can be modulated in respect to its amplitude, frequency, and phase. Such modulations are termed as amplitude modulation, frequency modulation, and phase modulation, accordingly whichever is being modulated. Such signals are termed as amplitude modulated signals if their amplitude is being modulated with, with the message signal. Now consider a message signal xt is equals to am cos omega mt and carrier signal xct is equals to ac cos omega ct. Okay, these are the two signals that will be the basics of our modulation process. X of t will be the message containing the information and it will be a low frequency message, and xct will be a carrier signal which will have quite a large frequency. So amplitude modulation are further divided in 5 different communication: double sideband, double sideband suppressed carrier, single sideband, suppressed carrier, and vestigial sideband. Moving further, we'll discuss what is actually baseband and carrier wave communication. Message signal is a baseband signal, and when it is modulated on the carrier frequency, it is termed as a carrier wave communication. Often the messaging signal like voice, audio, and video are usually low frequency signal concentrated near to zero of the spectrum. Spectrum is like a coordinate system, just like we have x and y graph. It is in coordinate systems, and similarly in frequency domain, the x line is represented by a frequency line f line, and the y line is the amplitude line. So that's the spectrum. Thus, these signals are termed as baseband signal. So those signals which are concentrated near to the zero of the spectrum, which have low frequency content, are known as baseband signal. Such signals can be transmitted only through coaxial cable or copper wires. Earlier, thousands of kilometers of cable were spread out from door to door, making connectivity possible for low frequency signal to propagate, and can be heard on either side through telephone as the end device. However, with advancement in technology, Voice propagation through mobile phones become prevalent. Here the media to travel was space, air. The low frequency signal traveling through space get absorbed in between and fails to reach receiver. Such limitation of baseband communication give rise to linear carrier wave communication. But I hope you have got why there is a need for communication or why there is a need for modulation. Baseband signals lacks the energy to be transmitted through the air. So they are modulated on high frequencies so that they can be transmitted easily through air without getting disturbed by the channel disturbances and get received at the receiver. Now look at what is a modulated signal and what is a carrier signal. No, actually in this figure I've just shown you only the basics. These graphs have been drawn with the help of a grapher, and you can see that the time period for both these graphs is different totally. For a low frequency having 2 Hz frequency of a message signal, a much clearer graph is formed having a considerable time period. A carrier frequency having large frequency content such as 100 Hz have a small time period. They are very congested in the time domain. Now you can see the modulated signal over here. The modulated signal so formed will superimpose the message signal over the carrier signal. Now you can see this is a AM double sideband AM signal 1 plus 0.1 0.7, and it is an under modulation signal. How I am saying all these parameters just by looking at the graph, you'll come to know when you move further through these video lectures. So this is probably it. The high frequency signal, carrier wave signal, taking the message signal along with them. Now let me talk about some of the parameters that can be calculated. First of all, power, modulation index, and modulation efficiency. These three parameters are calculated for amplitude modulation and considered to be very important. Now, power of a modulated signal can be calculated using carrier power and sideband power. If you see, the spectrum will be like in frequency. If we are talking about a frequency domain, it will be like a power at here, a sideband power at here, a sideband signal at here, and another sideband signal at here. This will be the spectrum of a double sideband having an amplitude AC at the center and AC mu by 2 at the sidebands. Now modulation index mu of a modulated signal is equals to amplitude of message signal divided by the amplitude of the carrier signal. Amplitude of message signal is AM and amplitude of carrier signal is AC. Now, if you wish to have an overmodulation, then mu should be greater than 1. For 100% modulation, mu should be 1, and for an undermodulation, mu is less than 1. If mu is equals to 0, then no modulation have occurred. That is, no superimposition of message signal on carrier signal have taken place. Efficiency of modulated signal is power of sideband divided total power, which is given by this formula. Now look at this gate question. Pause for a minute. Don't go on the solution right away, though I have given you. Let's start with explaining the question to you. You can also try it by yourself. This is a very simple question. The unmodulated carrier power is an AM transmitter is 5 kilowatt. The carrier is modulated by a sinusoidal modulating signal. The maximum percentage of modulation is 50%. That means mu1 is 50%. If it is reduced to 40%, then the maximum unmodulated carrier power in kilowatt that can be used without overloading the transmitter. Overloading the transmitter here means that it should not exceed the total power. So I have mentioned like mu1 is this, mu2 is this, and power of carrier is AC square by 2. Total power of a double sideband is given. AC square by 2, 1 plus mu square by 2. Or you can say PC is equals to 1 plus mu 1 square by 2. Now on solving, PT is 5.625 kilowatt. Keeping PT constant, the new PC at modulation of 40% 0.4 will be 5.21 watt. Okay, so instead of 5 kilowatt, we'll be requiring 5.21 watt if we wish to send a signal on a modulation of 0.4%. Okay, now moving forward,